Hello, this is Mrs. Boots, and we're going to work through our models for logs. So with the first three, we're given the table of data, so we plug that into the stat function, so we go stat edit. In L1, we put in the x values, 1 through 6, and in L2, we put in all of our y values. Remember, there has to be the same number of values in L1 and in L2. Then we quit out, so second mode, and then go back to stat, and you're going to scroll down to ln reg. So we're using our natural log. We don't have a regression for a log with a base or with base 10. We just have one for the natural log. And so we're going to use that on all of these, and that's selection number 9. So when I punch that in, I get A is equal to 1.99 and B is equal to 1. So I plug it into the equation. So I have y equals 1.99. I'm going to round it to the nearest whole number, which is 2, plus my b, which is 1, and then I have ln of x. So now let's look at the domain. So I'm going to go to y equals, and I'm actually going to graph that. Okay? So we graph it on our graph, and we see that nice, pretty curve. So my domain almost goes to 0. So we're going to go from 0. Remember, 0 would be the asymptote, and then it's going out to positive infinity. Remember, the range for logs is always infinity to infinity, so we don't have to worry about that. And our asymptote would be at x equals 0. Easy enough. Let's look at the next one. Number 2. Again, put all the x's in the L1 column and all the y's in the L2. So I go stat edit. And notice the x's are the same as the last problem, so we don't have to change those. We just need to change our y values. Now let's look at our equation. So I go stat over 1 to calc, and I select number 9. That's my ln reg. It's not the same as lin reg. Lin reg, L-I-N, would give us a linear function. So A is negative 4.985. That rounds to negative 5. So I have y equals negative 5 plus B, which is 4.99, which would be 5, times the ln of x. Now if I go to y equals and put that in my graph, I see that my domain is going almost to 0, but not quite. So we're going to go from 0 to infinity. Remember, 0 is the asymptote. So x equals 0 for my asymptote, and my range, as always for logs, is negative infinity to positive infinity. Number 3. Once again, go stat, click on edit. Our x's are in L1. We've already got them there. And now plug in these y values. These look really close together, but that's okay. Let's look at the equation. So I go stat, over to calc, and I select number 9. The a value is 17. That's awesome. So I have y equals 17 plus, and I get 0.5. Well, we can write 0.5 or half ln of x. So now I can go to y equals, and I do 17 plus 0.5 ln of x. And let's look at the graph. So notice at 0 it says error. That's because my asymptote is at 0. If I look at the table, if I look at the graph, it's way up high because we shifted it up 17 places. The range still goes from negative infinity to positive infinity. We don't even have to look at the graph from that. And since the asymptote's at 0, we're going from 0 to infinity. And remember, it's a parenthesis because the asymptote is not included in the domain. So now in the next 3 problems, because we do not have a regression for a log base 10 or log base anything else, we wanted to look at the tables of data and see what it would look like if I did have this function. So in your y equals, put in 5 times the log of x minus 2. And then I want you to hit second graph, so we look at the table. Okay, so x minus 2, remember this, if I'm going for transformations, is going to move it to the right 2. So that asymptote just moved it to the right 2. So am I surprised that at 1 I get an error, at 2 I get an error? The 2 tells me where my asymptote's at. So I have my asymptote at 2. So I'm going to come in here and put a nice dashed line for the asymptote on the graph. Now let's look at some other values. At 3 we get a 0. At 4 it's 1.5. 5 is 2.38. You could have used 2.4. It's fine. 6 is 3.01. Now obviously I can't graph to that level of detail, but that's okay. We already know our range is going to be from negative infinity to positive infinity because it's a log function. And since the asymptote's at 2, I'm going to go from 2 to infinity. So what would the curve look like? Well, at 3, it's at 0. At 4, it's at 1.5. At 5, it's at above 2, a little above 2. And at 6, it's about 3. So it's coming up and going out to the right. Number 5. Okay, I'm always looking at my table first before I look at my graph. So I scroll in my table. I know I want the values 1 through 6, but I'm scrolling and I see an error at negative 1. So my asymptote is at negative 1. Whatever we got the error at, that's where the asymptote's at. Okay, let's find the rest of the information. At 0, it's at 7. Well, that's not surprising because we moved it up 7. Okay, at 1, we're at 6.699. Then I have 6.52. 6.39, 6.301, 6.22, and 6.15. Really close together. So let's look at this. At 0, it's at 7. So right there at 0, we know our asymptote is at negative 1. And it's going down. Why is it going down? Oh yeah, there's that negative in front. Remember that means reflect. Right? We're reflecting. So my curve is going to come down. Plotting 6.99 and 6.65 and all of that, that's going to be a little tricky on the size of my graph. So we're going to approximate it. That's generally what it's going to look like. So here's our last problem. I know, we made the assignment way too short on this one. So let's plug in. We have 0.5 times the log of x. Make sure you close the parentheses, plus 4. So I'm going to go to my table. And notice at 0, I have an error. That means my asymptote is at 0. So I can go ahead and put that on my graph. Put a nice pretty dashed line right on top of the y-axis, because we're not going to touch it. Now let's fill in some values. At 1 we're at 4, then it goes 4.15, 4.23, 4.3, 4.35, and 4.89. Notice I rounded to 2 places after the decimal, and that's okay. Oh, that's 4.389. Wow. Okay, so now we start. I go from 1, I need to go up 4, and then it's going to go up little bit by little bit. So we're coming, let me change colors. Comes down and goes up like that. So it's going down in between the 0 and the 1, it goes to negative infinity, right? So our range is still negative infinity to positive infinity. And the domain goes from 0 to infinity. This concludes all of our practice for the log modeling. Okay, I just realized I forgot to do the domain and range on number 5. So I'm going back to do that. Our range is negative infinity to positive infinity because it goes up and goes down. Our domain starts at -1, where that asymptote is, and is going to go to positive infinity. Now we're done with our practice.